All right, so in this warm up, I'm going to give you some pieces of advice in how to attack, a table, graph, velocity, acceleration type problem. And the first thing to understand is think about what graph they are giving you. We've mentioned this. We've mentioned that velocity is the derivative of position. So it goes position, and then the derivative of that would be velocity. And we haven't really talked about acceleration yet, but the derivative of velocity is acceleration. Okay, so it goes position, velocity, acceleration. And right off the bat, it's important to see where are you in the problem. They give you the velocity graph, not the position graph. Okay, and oftentimes, I know we haven't really gotten into the second derivative yet, but in the next chapter, we're going to get into f, f prime, f double prime. AP loves to live in f prime. They love to give you information about f prime. And the reason they do that is because then they can ask you questions about f and ask you questions about f double prime. So that's where they love to live. And so first things first, identify where you are. We are in the velocity graph right here. Okay, so now A says, during what intervals of time is the acceleration of the car positive? Give a reason for your answer. Okay, well, now we need to think about what is acceleration. Well, acceleration is the derivative of velocity. In other words, acceleration is the slope of velocity. That's how you guys need to think about acceleration. Acceleration is the slope of velocity. So in other words, what this question is asking is, where are the slopes positive of this graph? Where are the slopes positive? Well, the slopes are positive here, 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 here. If I would draw the tangent lines would all have positive slope all the way until I get to t equals 35. And so, again, the question is saying, where are the slopes of velocity positive? That's how you need to think about acceleration. So that happens in two places. It happens from 0 to 35. So that first interval should be 0 to 35. And then also it happens again right here from 45 to 50. And so I want you to think about, we talked graphically a few classes ago, maybe 3 weeks ago or so. We haven't really gotten into graphs a lot lately. But really, when they're saying where is f prime positive, that's anywhere f is increasing. Anywhere f is increasing, f prime is positive. And so when they say give a reason for your answer, well, acceleration is going to be positive anywhere that velocity is increasing. That's how you're going to have to justify your answer. Anywhere acceleration is positive is where the velocity is increasing. So we would say that it's over these intervals because velocity is increasing. Over these intervals. But again, just identifying the relationship between position, velocity, acceleration. Okay. B, find the average acceleration. So in other words, find the average slope or average rate of change of this graph is what they're thinking about. Find the average rate of change of this graph over the interval 0 to 50. And when you're thinking average rate of change, think slope formula. That's what you're doing here. They want to know the average rate of change of the velocity. So we would just do the slope formula from 0 to 50. So I'm going to kind of do this down here. In other words, the slope formula from 0 to 50, we would do 72 minus 0 over 50 minus 0. And you get, if you reduce that, 36 over 25. That is the average rate of change of velocity. That's what acceleration is. Acceleration is slope of velocity. We're looking for the average slope of the velocity graph from 0 to 50. Now, as far as units go, it gives you the units here, but I want to address that really quick. When you're dealing with velocity, it would be like feet per second or meters per minute or whatever it is. Acceleration would be, in this case, feet per second per second. So it'd be feet per second squared. So anytime you're talking about acceleration, your units are going to be, well, whatever your units are, per time squared. So velocity would be feet per second. Acceleration is feet per second squared. C. Find one approximation for the acceleration of the car at t equals 40. Notice it says approximation. If it wanted to know the exact slope at t equals 40, we would have to know more information about this. We'd actually have to know the function value here. For those of you that have had stats, you cannot use any sort of regression for these problems. On the AP Calc exam, you can't use anything with regression. So just kind of get that out of your mind. We have no way of determining what the function is. That's why it says approximation. So if we want the approximation of this slope of the tangent line, we'll pick the 2 points that you know closest, so here and here. And if we find the slope that connects these points here, notice it's going to be pretty close or pretty parallel to the slope of that instantaneous rate of change. It is an approximation. Is it the exact answer? No. But we could find the slope between the 2 points nearest to t equals 40. So if we're looking at the table, if t equals 40 is right here, well, let's just find the slope between 35 and 45. Notice it says one approximation. AP made a change a handful of years ago. This is from 1998. This is an AP problem from 1998. And they used to let you go, as long as it was equal intervals away, they used to let you go any equal interval away from what you were looking for. Well, since then, they've gone, you need to use the two that are exactly on either side, in this case of t equals 40. So we would do 81 minus 60 over 35 minus 45, and you get negative 2, and then feet per second squared. And notice it should be negative. It should be negative because the actual slope of the tangent line at 40 is negative. And just a little connection to make there. So to recap, always identify where you are, whether you're dealing with position, velocity, acceleration, or whether you're dealing with f, f prime, f double prime. I mean, it is the same exact thing. These associations are the same exact thing. We do so much next chapter with this that you're really doing the same thing. And I think some students tend to freak out when they see position, velocity, acceleration just associated with f, f prime, f double prime. It's the same exact context. All right, good luck.